So let's take a look at our last intermolecular force, and that is an ion-dipole force. And an ion, of course, is an atom or a molecule that has gained or lost electrons. So I could take something like the sodium ion, or we could take something like the oxygen ion. Okay, and a dipole, of course, that's a difference in charge. So one end of a molecule has a positive, one end has a negative charge. So for instance, we could take a classic example of a molecule like water. So water has a dipole moment, and it points in this direction. So the oxygen is more electronegative, so it pulls electrons towards it, away from the hydrogen that is less electronegative. And so that ion there on the water, that dipole there on the water, and that ion there dissolved in the water, which is, I guess, what I was trying to say. There is an intermolecular force between those guys. So I'm going to draw that as kind of a blue dotted line there, and so that is my ion dipole intermolecular force. And if I look at the oxide ion, then it's the same deal, but now because oxide is negative, the hydrogen side of the water molecule will point towards it, because the dipole moment then has to be aligned up. So the positive end of the dipole, right, is next to the negative ion, and so we get an interaction there as well. And I can go ahead and I can dot that in blue, so that's my ion dipole intermolecular force. Now the forces themselves are proportional to two things: the charge on the ion. So I'm going to go ahead and put that in absolute terms here. So charge on the ion, so a 2 negative and a 1 positive, right? I'm going to say this is twice the magnitude of this, so it'll have twice the attraction here. So this will be much, much stronger. And it's also proportional to the dipole moment itself. So the bigger the separation in charge, the bigger the attraction. And so that makes sense. So the more polar a molecule is, right, the more attraction we see here. Now this is an interaction you can probably feel with your hands as well. So if you dissolve salts in water that have very high charges, 2 positive and 3 positive, I mean, sometimes they don't dissolve, but if they dissolve, that attraction between the water molecules and the ions can be so significant, right? It releases a ton of energy and it gets very hot in the process. So if you've ever taken the calcium chloride and you've dissolved it in water, and it gets pretty warm as you top it in there.